Now, Ashish will be co-hosting with me. We did have Vandana before doing, and thank you so much, Vandana, for co-hosting with me all this while. We do have Steve now with us as well, and I'll bring him on. And Steve, hi, Steve.
Hey, Steve. Wow, camera quality is amazing, man. What do you have? Like an SLR? Oh, you're mute.
I think you're on mute.
Rookie mistake. I just spoke about hybrid remote, and you just did the rookie mistake of having yourself on mute.
I started off the thing with being on mute, so I think I've already popped that.
Classic. Yes, right, yes, I have an okay camera.
Just an okay one.
It looks like I'm looking through a glass, man. I don't know how it's an okay camera.
We like to see Steve, quite clear. And Steve, you're talking about Pwning the CI workflow and how to prevent it. So if you're ready to go, we might give the stage to you and let people hear about your talk.
I'm ready to roll.
Amazing.
Good luck.
Thank you. I'm going to need it. A lot of moving parts. All right. Let's go. Some great talks. Wow. She's always very difficult to follow, but I'm going to do my best. I haven't got a dog in the room, but I will, I don't know, maybe bark myself a little bit if somebody comes nearby. This is Pwning the CI, the GitHub Action Edition. Welcome. My name is Steve Giguere. Let's do the obligatory little bit about me. I'm a developer advocate for Bridge Crew. I've been writing code since 1990. Actually, it should be 80. It's even more embarrassing. I was involved in quality automation, which is in automotive, oddly, very Gene Kim. And I've been doing cybersecurity since 2014, working for a bunch of companies. I am co-organizer of the DevSecOps London gathering in London, of all places. What a surprise. I have a cloud native security Twitch show called C9K, and I have huge jet lag and a cold because I just spent a few weeks in Canada seeing my family. I'm based in England, so I feel awesome right now. If you would like to connect to me and you just like to randomly click QR codes, we'll do a whole other talk about that, but there it is there. All right, brief agenda, just talking about what GitHub Actions are, what could possibly go wrong, different threats, different styles of insiders, and the attack vectors associated with that, and then a little bit about prevention so that we have some takeaways here today. GitHub Action workflows. A lot of the GitHub Actions content I'm putting in here, I'm taking straight out of their documentation because I don't want to misquote, and I think it's important that people get familiar with the documentation that is available, and this is a quote directly from there. Workflows are defined in the .github/workflows directory and repository, and you can have multiple workflows. They can do a whole bunch of things, and the examples that they provide already are, for example, a workflow to build and test pull requests, deploy your application, or maybe add a label every time someone opens a new issue. These are just some examples that you can do. Very simple example here, again, straight out of the docs, just to break down what it looks like written here in YAML. On an event of type push, then certain steps will run, and you can see will run on a runner. It can be a GitHub provided runner, or it can be a self-hosted runner. And we'll get into that, why that can be considerably more dangerous should any of these things I'm about to do become realized in your repository. So you can check it out, install, run, and et cetera, et cetera. There's a whole load of things you can do with them. Very, very straightforward. The fundamental problem we're coming up with here is that GitHub can and often will run new workflows in the GitHub workflow path, even if those workflows are the commit. Metadata issues like issue name, issue description that are associated and may be visible to workflows are often used as unsanitized inputs in a very sort of traditional AppSec kind of way. And finally, the workflow directory shares the same access controls as the entire repository by default. There are ways you can mitigate that risk, and we'll talk a little bit more about that in a moment. And in reality, this is not your ideal scenario, is it? There's a lot of power in that workflow directory. Now, a few GitHub action attack vectors. Okay, well, we've got the three different categories there, adding a label, build and test, deploy your application. Well, what if I were to try to execute a command injection via creating a new issue? Perhaps I could, well, we'll see what we could do. No spoilers. A workflow to build and test pull requests. So I could push a new workflow using the GitHub API to bypass the required minimum approval. Okay. Or pardon me, a workflow to deploy your new application, well, that might mean I have environment variables that might be damaging to particularly if I'm on a self-hosted runner. So what if I tried to exfiltrate all of my environment variables, maybe and my secrets? What if I were to, I don't know, could I create a reverse shell via a workflow? There's a lot of things I could do given the right credentials. So here's my attacker's guide. This is probably a really bad slide to have. If there are any attackers viewing, hopefully all defenders. My plan A would be a very simple external attack. I would submit a workflow. I could be new to the environment. Now, when that happens, we can see over here on the right, it doesn't automatically run my workflows. There is a button there that says approve and run. Now, the confusing thing about that is that unless I click on this learn more very subtly here, and I will be taken to the documentation that you can see above. That does provide you a warning that says you should be especially alert to any proposed changes to the .github workflows directory. But it's not a big red flag with the sound to tell you this is a first-time contributor who's never run anything, who's submitting something to the workflows directory. That is a, let's say, indicator of compromise kind of thing. It's bad. But the reality is that a lot of your workflows are there to check code content. So there's a lot of potentially security checks in there. And your instinct might be to click approve and run. Why wouldn't I want that? I want to check this content. So if you're not careful and you do just click that, bad things can happen. The second, of course, is plan B. If you're not going to be so bold, become a malicious insider. Submit some good first-time contributions, maybe a README, maybe some actual helpful workflows to an environment, being a force for good, and then attempt to become a collaborator where what you can do radically changes. What's interesting is that the GitHub defaults are pretty good. Like GitHub is very secureable. It's a little bit like the cloud, but it's not necessarily secure by default. I think that's one of the key takeaways here and what we're going to try and learn from this talk. All right. Now, here's an example. This is a real-world nonfiction example of what happened in our actual environment. I work on an open source project regularly called Chekhov, and we had a pull request. You can see it's closed, called build.yaml. And this is what it looked like. They had, I'm thinking, our conclusion is that this was somebody else's account takeover, and this was a bot that came in. It deleted our entire build workflow and changed it to, and you can see we run on self-hosted, right? So this is bad if this had happened. It just ran a PS and an env, and that was going to, the results of which would be in our logs, which could have been bad, exposing all sorts of things to our GitHub logs that this person could then read. Now, this came in and the approve and run was there, and we did not click the approve and run. It was so blatant, it was ridiculous. But this was out there. This really did happen not that long ago. All right. Now we're going to do number one. And in order to do that, though, I need to introduce you to the characters involved in this story. There is a webhook receiving site. This is webhook.site. If you don't use this in demos or for debugging, it's amazing. Just creates a receiver for API calls. I have this malicious character called Loud Canadian. And over here, I have Steve G, who has created a repository. Very simple. There's nothing really in it. It's brand new. And it's just a README. And I have a default. This is the default. If you just create an action and it says, what's the basic one that you have created? That they give you, just so I have a workflow directory created. That's all I've done. I haven't created anything special else in here. Super, super simple. And now I'm over here. I, as Loud Canadian, the trusted, everyone trusts Canadians, right? So I'm looking at this and you're okay. All right, great. So what I'm going to do is I'm going to fork that. So I have a copy of it in my own world. And I can start to create contributions to it. Wonderful. How about that, right? So what I'm going to do is I'm going to create a workflow, actually. And we'll see all those things I just said play out. And I have my workflows directory. Looks pretty good. I'm going to add a file. into here, and it's called issues check.yaml. Looking good so far. So I'm being helpful to this repository. I'm a good person. I am. Any open issue, it's going to check the title to make sure it adheres to a certain format. I like it. I'm going to commit to my main. Yep. Now, this is just locally at the moment, right? You understand that. Looking pretty good. I have one commit ahead of Eurogig main. Seems pretty good. I'm going to create a pull request back across. Fantastic. Looks good. And I should have a pull request over here now. Now remember what we saw earlier, the approve and run. There it is. Because I'm not a contributor anymore. So this is good. Now I'm also committing a workflow that will not trigger because it only triggers on new issues. I can check the files changed, and I can say, oh yeah, I like that. I like that this person's helping me. I'm okay with that. And so that's not a big problem. I could approve and run because I do want my checks to run. And you can see that default one run, all it does is print out readmes. And it's okay. I know I can confirm and merge this. It's not going to be a problem. I can go look at my actions here and see that it's in progress. It all passed. I'm a bit now. Eurogig is a big fan of Loud Canadian, so we're going to merge that because they're so helpful. Wow, thank you, Loud Canadian. Now I don't have any special privileges here, nothing at all. And so what I'm going to do now is I'm going to create an issue. Maybe I get my friend to create the issue. And my issue is going to be called, now before I do this, well, no, I'm going to do this now. Yeah, we're going to go ahead first. We already started the demo, so let's do it live. And my issue title is going to be extremely readable. There. Just a normal issue. Okay. That's a crazy title, isn't it? Now, that was a new issue. So really, realistically, this action should kick off. And there it is. Now it's queued up because it doesn't have priority. There it is. 12 seconds. It's in progress. It's running. I guess my title was legit. Uh-oh. What's happened over here? What did I do? I piped an env to a curl and sent it out to my webhook site, and now I have all of the environment variables. I have kind of accomplished what that person was trying to accomplish with us, and I've done it completely as an outsider by sending something very innocuous in that was just checking issue titles to make sure that they were sane. I was actually actively doing input sanitization, and in the process, you did something that kind of circumvented and created my own lack of input sanitization, which is bad. And that's essentially what just happened. Now, how real is this problem? If you search on GitHub the entirety for bad things, you see people doing things like this all the time. Like there's one example where somebody is actually generating a Hugo website based on to show how well they're handling actions and creating the post title out of this GitHub event issue title. Now, if I were to say create a title that was session expired, please log in, form action, etc., I could actually, when someone went to look at this title, which was generated through GitHub, I could pop up a mock GitHub login and say you were logged out and start, getting GitHub credentials. Bad. What's the other one? Well, searching other users and metadata found thousands of examples where people are doing what I just did. I didn't even straight up echo. I just copied my issue title into a variable. But because it was in quotes and I used those backticks, it reconciled the meaning of that backtick command because it's still running in bash. And it then, my quote became all my environment variables. And then I was able to push that out to an external source. So lesson 1. Input sanitization. Be careful what you do with this metadata. It's really important. We already gave it a try, so we can skip. Now, what can you do with environment variables? Wow. On a private runner, There can be cloud or AWS secrets available, passwords, connection strings. I can change logging level and by that gain access to sensitive data and logs, all sorts of things that can be on there. I can potentially even gain access to the GitHub token and enable code modifications. There's loads of things I can do by gaining access to a self-hosted runner in particular. How can I protect environment variables? Well, here's a little dabble into prevention. There is something called environment protection rules that, in a summary, this is again cut and pasted from the GitHub docs, and there's a link down there. It's really long, but I have it again at the end. You can scope the environment variables and the secrets to certain workflows. So a new workflow wouldn't have access to all of this, particularly so only production, say, would have access to production details. So this is how you prevent something like this from happening, and the information is just there. But more often than not, these aren't in place by default, and it takes a more astute security team and knowledge of GitHub to make sure that this is done appropriately. All right, hack number 2. Now, hack number 2, I'm only going to do in combination with 3 in the interest of time. But just to give you an idea, and introducing branch protection rules. Branch protection rules are off by default. There are a lot of tools you can automate to check that they are turned on, and we'll talk about that at the end. But when you first turn them on, there are some great defaults there. Defaults, or when they're on, of course, can be good, but can be not necessarily perfect. Now, for example, when I first turn on my branch protection and I tick require a pull request before merging, sounds awesome. It says require approvals. Great, I turn that on. The important thing to notice there is that there's a really subtle 1 there. You really ideally want that to be 2, or use what we call a code owners file in GitHub, and I'll talk about that a little bit more later. But that's a very circumventable number, and we'll see why. If I want to submit a pull request with a new workflow, it's possible, if I'm a collaborator, that the GitHub token gives me enough access to auto-approve myself. And this is just a quick example of what that looks like. Now, I'll show you what that means in a moment, but something that's key there is I need to be a collaborator. Caveat as of early 2022. Now, this happened while I was creating this presentation. The settings within GitHub changed for a particular repo, and it's worth noting this. So if you look under the GitHub action permissions for workflows, there is now 3 tick boxes. Read repository. Now, this example I have right here is the correct example. This is how new repos tend to get created by default. But any repo that was created prior to around April 2022 doesn't look like this. Instead, it looks like this, because this is legacy. This is what the permissions were before April. And that is probably still 99% of all repos out there still have these settings set up, which means a GitHub token does have the ability to read and write permissions, and does have the ability to create and approve pull requests. So because that was the default, and this was some research, I think it was created, I want to say cybersecurity, but I might be wrong there. But they did some research and found this and disclosed it, and they changed this. But that does mean that the default is still wrong. All right, so this is hack number 3, Pwning the runner, and this will include the approval. So what can I do with a GitHub token? A lot. Primarily based on the permissions and the timeouts available. Let's talk a little bit about the timeouts. A GitHub token lasts for a maximum of 24 hours. Okay, so that's a lot of power for a lot of time. What usage limits? How long does a GitHub action job last? So that would indicate another limitation. Well, the job can last up to 6 hours. I can get a lot done in 6 hours if I have a token. How can I get that token? And what permissions do I have? This is a confusing part of the GitHub documentation, I find a little bit, because the default access, there's 2 defaults, restricted and permissive. Now, restricted is what I had. Permissive is kind of what I want. And the final warning is that if you look in the documentation about GitHub tokens, if you don't have the permissions you want, the suggestion they give you is to create a personal access token and save it as a secret. That might have a lot more permissions. And what if I can exfiltrate secrets? Well, then I kind of can potentially get the keys to the kingdom there. All right, so here's an example workflow that I'm going to use in a moment. And it's a little zoomed out. So let me just zoom in a little bit on this little bit right here. What I'm going to do now is I'm going to echo the secrets into a file, and I'm going to push those secrets out to my bad URL. And then I'm going to do my environment variable one. Same thing I did with the issues. So I have all my environment variables. So now I have my secrets and all my environment variables, if this works. Already sounds bad, doesn't it? The hacker scenario around this, and this is a real possibility based on just looking around GitHub. Now, I hope I articulate this properly. The reality is, if I'm a baddie, I went looking for site or actions that insist you make a personal access token. I found one that was called, I think it was called AutoMerge++. I may have changed the name to protect the innocent. And its instructions were to create a personal access token with AutoMerge for AutoMerge. So it had the ability to merge PRs, which sounds pretty powerful, and it is. So what could I have done there? Well, I could have become a part of that so that I could, just almost like what I did, push a README, do some good work, get access such that I can become a collaborator on that project. You probably think this sounds like a lot of work. It is. It's perhaps far-fetched to an extent, but it's still possible. And I can then submit a workflow. Then if I can do it right, can exfiltrate that secret. Once I have that access token, I can now submit code that I can merge myself. And if I can merge my own code, then once that code is in, I can start pushing that code at scale to other people. And the example I found was a company that used the auto merge to create further GitHub actions that were then used at scale. So what you end up here with is a very not traditional, but a serious supply chain attack where I'm able to manipulate code based on a token that can auto merge PRs that will be then create code that will be used by other people. Complicated, but maybe I need to rethink that diagram if that wasn't clear. Once again, we have a way to protect environment variables and secrets. And so here's what I could do. I could pause and give myself access to that token to do things. Or if I wanted to be a little bit even more mean, I could do something like this, which is a reverse shell. Okay, let's try it. Now, some things I need to do beforehand is, let's assume I've been a good boy and I've not automatically tried to create an issue that exfiltrated secrets. And thanks to good behavior, I have been added as a collaborator. So I need to do that. I need to go in here and say, all right, I really like this loud Canadian. I'm going to make him a contributor. There we go. Which is going to change what I can do and how powerful my workflows are. We can see that I've been invited to collaborate. I have to agree. I once did this presentation where I forgot to click accept, and it really does make a massive difference. Now I can get back to here. What I'm also going to do is the preventative measures that I just showed you. I'm going to add my branch protection. Main, oops. I'm going to require, there we go. Now, I mentioned code owners. We should do code owners, but I'm not going to do it this time. But here we have one merge. Now you can see here, branch protections are absolutely essential. All it requires status checks, include administrators. These are all the things I should do. Don't tick these. But what's interesting about allow force pushes is that unless you have a branch protection rule, you can do a force push. So there's a lot of important things or defaults that are really effective. So we're going to create that. Excellent. And we're going to go down. Remember those workflow permissions I was talking about? You can see I've got read and write, and I can create and approve. So everything is set up for my attacker now. But I do have branch protection on. So here's what's going to happen. Let's do a few things. One, I'm over here waiting, and I'm going to listen at my remote command and control center, let's call it. It's kind of a big finish. I hope it works. I have 5 minutes. I'm going to create a new file. I'm just going to call it called pwn, really obvious, pwn.yaml. Okie dokes. Let us, I'm not going to type it all out because it's way too long. There we go. Looks lovely. Now we can see I've got the approved thing I just put on the screen. I've got a few baddies down here as well. And you can see, look, I've got branch protection on, so that looks good. I'm going to create a new branch. I'm committing back. I'm going to propose this new file. And create a pull request. Let's look at it through the eyes of our receiver here now. Now review is required. That's awesome. And you can see it's queued. It's going to run my workflow because remember, I already got past that hurdle. Oh, look, my changes are approved. Hey, fantastic. Who approved that? The action bot. That was step 1. Uh-oh. I have a shell on my runner. All bad. I wonder what's happened over here. I have my GitHub token. I have my Postgres password, my AWS key. Oh boy, that's not good. And I have all my environment variables off one workflow. It didn't take me long to get there, did it? Now there's a sequence of, in the interest of time, there's a sequence of things I could do over here to really create a whole load of other problems. For example, I could run a git fetch. I can see my new branch. And I could do a bunch of kind of really bad things over here that can change the state of what's happening over here. Now, I'm not going to quite do that yet. Well, maybe I will, but I can. What I can do is I can delete the entire. I have enough credentials over here to delete the pull request and make it so that the pull request is just completely gone. Now I realize I only have 2 minutes left, so I'm going to progress with the lessons learned here. I just had way too much credential on that, and the end result would be I would have persistence on the runner, and yet the pull request would be deleted. Now you can imagine how bad that would look. I could run reverse shell and potentially while self-concealing how I did it. I could even do a new commit that deletes what I previously created. So I could delete the Pwning file, I could delete everything, and I could make it look like somebody else did it. So ounces of prevention. Be careful when adding contributors. Turn on branch protection. Do not run workflows unless you're 100% sure. Use environment protection. Do not add permissive tokens. And some nice to haves. Single sign-on. Scan your container images. And use events to log activity. And I mentioned the code owners file. What I really should have done is I should have had a code owners file in the .github directory that said only certain people can approve workflows. That changes the RBAC essentially. Automating your security is 2 ways to do it, I think, that I'm a big fan of. One is using the OpenSSF scorecard that has checks to make sure branch protection is turned on. It looks for some of the things I did in terms of dangerous patterns for workflows. And it also has checks to see you have more than one person as part of your organization as contributors. And of course, the project I work on, Checkoff, also does scans for exactly the sort of things I was doing. It's looking for reverse shells. It's looking for exfiltration of secrets. It's looking for curl commands. It's looking for every bad thing I did could be prevented by running a Checkoff scan on your workflow prior to checking it in or upon arrival. I'm out of time, so we won't try that. But the key takeaways here are design takes a lot of work. Defaults aren't secure. Use automation for security. And I'll stop there. I almost got it done in time.
Great job, Steve. Now I know how to hack.
Positive.
That was a really, really good finish to DevSecCon 24. Just seeing things live is always a really good, it's a good way to learn. And kudos to anyone who does it because there's so much that can go wrong in a demo. So you were very calm throughout it and it looked like it all worked perfectly.
Demo
so well
done. Yeah, you can pat out that sweat now, which is very clear on your SLR camera.
Thanks.
Definitely.
I agree. It was amazing, and especially, oh, Canadians, you're amazing. Canadians, you're amazing. And the way you were flowing through, it was so amazing. Totally love the energy.
Thank you. Thank you. I'll do my best.
Yeah, Steve just tries his best and turns out to be the best. Is probably setting a new standard. Pretty awesome, man. Thanks for finishing up as well. It's really great to have you.
No worries.
Thank you
Thanks,
so much
everyone.
for joining us.
Cheers.
Thank
Thank
you.
you.
Thanks, Steve.